Okay, so the second talk in this session is by Ian Rigby and Elsi Kaiser, and it will be given by Elsi.
Great. Thank you, and I hope everybody can hear me. Let's see if I can get the clicker to work. Yes. So I'm Elsi Kaiser, and this is work that's actually led by Ian Rigby, who is with us today on Zoom. So he's going to jump in and help me with any hard questions you guys might have. All right. So I'm going to start with a question, just because that's what everybody wants to do right after lunch. So here we have two shapes. And if I were to ask you which one's the Kiki and which one's the Boba, I'll give you a few moments to think about that. Now, hopefully, if you are like other people who've participated in these kinds of studies in the past, you will agree that the one there on the left is the Kiki and the one on the right is the Boba, the more curvy looking one versus the sharp one. And this is the well-known phenomenon of sound symbolism. The idea that the mapping between words and their meanings is not always fully, am I really loud, by the way? Okay, that the mapping between sounds and their words and their meanings is not always fully random, but that there can be linkages between, for example, here, certain phonemes and the shape properties that they refer to, like round and sharp. So the idea is that certain sounds, like the ones in Kiki, can evoke sharpness, and the phonemes in Boba can evoke round shapes. This is also known as the Takete-Maluma effect, and people have shown this not just for shapes, but for size, for affect, for like ice cream flavors, for Pokemon names, all kinds of stuff. And now if we think a bit more closely about the shape dimension, if I were to ask you to kind of categorize the Kiki and the Boba as round or sharp, put them into these two, into one bin or the other, seems like a really easy question, right? The Kiki is sharp and the Boba is round, no problem. Now, what if, just to keep you on your toes, we give you an ambiguous shape, where this shape here has some properties of round shapes and some properties that are sharp. Then if I were to force you to put it into one or the other bin, round or sharp, you might hesitate and might be like, well, I don't know, it could be either one. There's kind of like this tug of war between the two responses. And now let's say I give it a label. Let's say I call it a Boba, so it has here phonemes that we know are linked to roundness. Then perhaps this nudge could be what pushes you to say that it's round. Or conversely, if I were to show you that same shape and call it a Kiki, using phonemes we know are linked to sharpness, then perhaps this could break the tie between the two responses that you're struggling to choose between and nudge you towards saying it's sharp. So there's kind of this intuition that we've been thinking about, that sound symbolic cues can act as kind of a tiebreaker. So when you're faced with an ambiguous shape or an ambiguous stimulus of some kind, then you have to choose between two separate categories, then sound symbolism could kind of nudge you in one direction versus the other. But what if we ask a different question? If I ask you, how sharp or how round is the shape? If I allow you to now give me a more gradient answer, well, then there's no, it's not so tough, right? You could put the shape somewhere, perhaps in like the middle of that continuum, you know, depending, different shapes might be a little bit different from each other. But crucially here, in this kind of more general gradient assessment context, there's no need to break the tie. I'm allowing you in your response to indicate the shape in a more gradient way. So there's no tie-breaking role here. So we wanted to, in our work, in order to better understand the role that sound symbolism is playing or not playing, or what its extent is, think more carefully about these different types of tasks. So we're going to ask, how does the sound symbolism in a word, like Kiki versus Boba, guide the binary categorization or sorting of shapes? And we'll do this in the first experiment using a speeded binary categorization task. And this is a type of task, this binary sorting is a task that has traditionally been used in a lot of the sound symbolic work. In our second experiment, we're going to follow the path that I kind of showed you in the second part of the initial intro example, where we're going to ask, how does sound symbolism affect the gradient assessment of shapes? So if I don't force you to be in this cognitive mode of sorting or categorizing, what happens? And we'll look at this in the second experiment with the Likert rating task. Now, we're not the first people to have looked at sound symbolism. There is a huge literature with all kinds of interesting results. I'll just mention here a couple that are most relevant for us today. In particular, work by Sidhu and Pexman in 2018, they used a sequential priming task where they had shapes that were preceded by prime words, and those prime words had different types of cues to shape, sound symbolic cues to shape. And they found that in a binary categorization task, people's responses, whether they put something in the round bin or the sharp bin, is indeed influenced by the sound symbolic properties of those prime words. They didn't find effects on reaction time, though. And crucially, in their design, they had a temporal dissociation intentionally between the words and the shapes. They also had no communicative link between the words and the shapes, because they wanted to, in essence, see, can we get effects of sound symbolism, even if people have no reason to make a connection between the shape and the word we just presented you with. And the fact that they did find effects of sound symbolism in the binary categorization task, in the offline responses, is actually quite impressive, I think. But now we were thinking, language is typically a communicative thing, and often, not always, the labels occur when we see the object, even though we know from acquisition it's not always the case. But we wanted to ask, what if we create a communicative link? So we present the words explicitly as object labels, and going back a bit to some of the more traditional work on this. And if we eliminate the temporal dissociation, so we show the word and the shape at the same time, can we then perhaps boost the effects of sound symbolism and also perhaps see effects on reaction times as well, pointing to perhaps a more online component to this mechanism? Another earlier piece of work I wanted to mention, not linked to sound symbolism, but relevant for us, is work by Lupien, who has shown that the linguistic presentation of a category label can facilitate visual recognition of members of that category. So if participants were told to essentially find the target when they knew what the target looked like, versus when they were also given a label, kind of like find the bee, a linguistic label, they did better when they were given a linguistic category label. So linguistically naming a category seems to boost somehow, or make that category, in this case, more easily visually to find members of. So we wanted to ask, if we explicitly link shapes to linguistic labels with sound symbolic properties, kind of building on what I was saying before, this could be another reason to expect that we could enhance effects of sound symbolism by essentially naming the category. So just to kind of sum up so far, we have kind of two new ingredients, or one is kind of more traditional. We have a communicative link between the shape and the sound symbolic information. So we're going to present the critical words as names of the objects. We have temporary simultaneity in our design, so that the shape and the critical word will be presented at the same time. And we want to see, in this case, can we boost the activation of the shape category in listeners' minds, and therefore detect sound symbolic effects on their categorization responses. But crucially, as we saw in that initial example, we also really want to focus on what kind of cognitive process is the participant engaging in. Are they doing a binary categorization task where we're forcing them to sort the shapes into two distinct categories, two distinct bins, round or sharp in this case, where we might have this tie-breaking situation where they have to resolve or choose between two competing options? So is that the cognitive task they're doing? Or are they engaging in a more gradient task of assessing how sharp or how round is a particular object? And because we'll be using the same stimuli for both, we're in a good position to kind of compare whether the different cognitive tasks have an effect. So do they modulate the effects of sound symbolism? And now for our predictions, kind of the big idea underlying this is what we're calling the category activation hypothesis. So that a linguistic input signaling shape properties via sound symbolism, like hearing boba or kiki or takete or something, the idea would be that this could activate an abstract category representation in your mind for that shape. So hearing boba would activate the round category. This leads to two predictions. One, for unambiguous shapes, we expect to see congruency effects. So when a shape that's unambiguously round or sharp, in that case, if you get processing visual information about that shape, will be facilitated if you get a congruent sound symbolic label. Because the sound symbolic label will boost that like representation of the relevant shape, and therefore doing visual stuff related to that shape will be easier. Kind of echoing Lupian's work in an indirect way. The second prediction we have concerns ambiguous shapes, and these are informativity effects. So if you see a shape that's ambiguous between round and sharp, then we predict that if you get a label, then you can use the sound symbolic properties of that label to guide your categorization responses if it's a binary categorization task. And we also predict that the categorization should be faster, perhaps, when you have informative labels cueing either sharpness or roundness, than if we have uninformative labels, like with mixed phonemes or no labels. So in essence, congruency effects for unambiguous shapes and informativity effects for ambiguous shapes. So informative labels should nudge you in the right direction with ambiguous shapes, especially in a categorization task. So let's see what happens. In the first study, we used a forced choice binary categorization task, and we had, we actually carefully pre-normed our shapes. We did a separate norming study which we used to identify unambiguously sharp shapes, ambiguous shapes, and unambiguously round shapes. We had 12 of each in the main study, chosen from a larger set. We have some more examples, and we're happy to talk about how we created these as well, in case you're interested. Now, the auditory label conditions that we made for our studies were building on work by D'Onofrio 2014, who very carefully identified different phonemes, this is for English, associated with sharpness and roundness. So here we see consonants and vowels linked to round, cueing roundness in blue at the top, and another set cueing sharpness. So we use those to create round bias labels that had round biasing consonants and round biasing vowels like bubo. We had sharp biasing labels with only sharp biasing consonants and sharp biasing vowels like keti. Then we had combination conditions where we had a mix of sharp and round vowels / consonants, and also we had a no label condition where people just got silence. So these last two were control conditions. And I should note already here that D'Onofrio interestingly observes an asymmetry in her study. Hers was a kind of a binary shape choosing study. She found that the roundness cues seem to be stronger than the sharpness cues. This is something that hasn't gotten much attention in the literature, but she observed it. And so we wanted to test them separately in our work to see if that comes through as well. All right, so the procedure was pretty straightforward. People saw a shape and they heard a label. And also in the tops of the screen, they saw kind of the category labels, the two bins, round or sharp. The positioning of like the round and sharp sorting labels was counterbalanced by participant. And people then simply after they'd heard the label, then they had to click, and we got this green frames came up and people had to click whether the shape was round or sharp. And we had 93 people doing this over prolific. Yay, pandemic. Okay, or yay, prolific, I should say. That's what makes it possible, right? So what are our results? Let's look at the categorization data first before we turn to the reaction time. Here, we're always going to be plotting the proportion of round responses. And we have the shapes going across the bottom there on the x-axis, and the different labels will be the colored bars, as you can see. So if we look at people's categorization of the ambiguous shapes, the thing to note here is that blue bar that's sticking up above the other ones. So this is for the round bias labels. So if you have an ambiguous shape, you get more round categorizations when it's paired with a round bias label. this fits with this thinking that, okay, informative labels can help break the tie, nudge people in one direction than the other. What's interesting though, if you look at that red bar, that's when we gave people a sharp bias label, and that does not differ from the control conditions. So the sharp bias labels are not doing anything, whereas the round bias labels are able to kind of push people in one direction versus the other. So this is kind of a very strong illustration of the asymmetry that D'Onofrio kind of as suggested in her work. Now, looking at the unambiguous shapes, here the thing to note is if we look at the round shapes, when you see an unambiguously round shape and you get a sharp biased label, and that's the red bar, then you're actually less likely to categorize that shape as round than you would otherwise be. So there's kind of this anti-congruency effect here, right? And now sharp shapes, though, show no effects of anything. They perhaps due to a floor effect. And we can talk about that. But again, we are seeing effects even with unambiguous shapes, but again, this sharp versus round asymmetry. Looking at the reaction times, these results are a bit less clear, and we're still thinking about doing some further analyses. We're happy to discuss that. If we look at the ambiguous shapes, it looks like we do have some indication of informativity effects, so that if we have a sound symbolically informative label, in particular a round biasing label, this speeds things up relative to the control conditions. Sharp biasing labels do not differ from the controls. The relation between the round and the sharp labels is a little bit unexpected to us. We're happy to talk about that more. But again, we are seeing this asymmetry when we compare them to the control conditions, that the round biasing labels are showing clearer effects. Looking at the unambiguous shapes, here for round shapes, we do get some hints of congruency effects, that they're categorized faster with round biasing labels. Again, things are not quite what we expected comparing the round versus sharp biasing labels for the round shapes, but the sharp shapes are not showing clear effects. Okay, so what have we seen so far for the first study? With unambiguous shapes, we do get some congruency effects, in particular with the round shapes with the people's choices, and we get some hints with the reaction times. We plan to do some more analysis looking at contingent reaction times, and we can discuss that. For the ambiguous shapes, as I showed you, we do find that when people are faced with an ambiguous shape, getting informative labels, in particular round labels, can help nudge them in kind of resolving that tie in terms of how to categorize that shape. So we're seeing this asymmetry between sharp and round patterns emerging. In the last 2 minutes, I'm going to tell you about the second experiment. Namely, what if we take the same sounds and the same shapes and change the task into a Likert rating task? Do we still get these kinds of effects? So now, here people again saw the shapes and heard the sounds, but they instead rated the shapes on either on a scale of roundness or a scale of sharpness, 7-point scale. We didn't measure RTs because prior work suggests reaction times with these Likert scales are really hard to interpret. We had 72 new people. And what did we find? Looking first at the roundness scale, again, proportion of round responses on the y-axis and x-axis, the shape types. What do we see here? Okay, well, people are paying attention. The round shapes get the highest roundness ratings. The sharp shapes get very low roundness ratings, and the ambiguous shapes are in the middle. But if you look at those different colored bars, the different label conditions, no difference. We see the same with the sharpness scale. Now the sharp shapes get the highest sharpness ratings and the round shapes get the lowest. The ambiguous shapes are in between. So again, the people are definitely, they're paying attention, but no difference between the different labeling conditions. Those colored bars within each set don't differ from each other. So now we see no effect of label type on any shape. So when we switch the task away from a categorization task to this kind of more gradient assessment task, we see no more effects of sound symbolism. So just to kind of sum up, we get pretty asymmetrical results. Thinking about unambiguous shapes, do we get congruency effects? Yes, we do get them with the first experiment, in that we do find, like if you think back, we, for example, found that those round shapes, unambiguously round shapes, are still impacted by the label that they're presented with. But in the second experiment with the gradient task, we didn't see anything like that. with ambiguous shapes, again, in the first study with categorization, we did find effects of sound symbolism on people's responses, but nothing with the more gradient task. So where does this leave us? I think the big message we'd like to leave you with is that the effects of these sound symbolic effects are what I'm calling here context dependent, but I think it's really, you'd call it like cognitive process dependent, right? When the participant is engaged in a cognitive task of categorization, that's when we see effects of sound symbolic information kind of breaking the tie between competing choices. But when we put people in a more gradient assessment context where there's no need to kind of be doing this binary sorting, these effects are no longer detectable, at least using our current methods. We also did find that when we communicatively and temporally link the sound symbolic word to the object, we do get something happening with reaction times as well, contrary to prior work that didn't aim for these kinds of links. And we're seeing repeated effects of this interesting asymmetry in how round cues to roundness and cues to sharpness seem to be diverging. And that's something we'd like to think about more. Just as broader implications, something we thought people could keep in mind is there could be a lot of sound symbolic stuff happening in different experiments, for example, artificial grammar learning studies that one might want to be aware of and just keep an eye out for that. But for us, in terms of future work, a lot of open questions, still very much work in progress. We'd like to do more fine-grained work into looking at real-time effects beyond reaction time, looking at things like eye tracking in the visual world, to really get a better sense of what is the place of sound symbolism in the architecture of the language processing system, given that so far it's there sometimes, not there sometimes, depends on the task, and we think that is quite revealing. But I'll stop there and thank you for your attention.
Thanks very much. We've got time for a few questions. Any student questions? Okay, so let's go ahead.
Okay, can you hear me? Hi, Elsi. I'm Amanda Riesling, University of California, Santa Cruz. So happy to come to the UK to talk to you. Hi, Ian. I wanted to ask, I'm not sure which of the two things I'm about to ask you I should go for first. So if you've considered running non-speech analogs here, and if you've considered where you think the basis of the sound symbolic associations might be coming from. So when I look at the phonemes that D'Onofrio identified as round, they all have a lot of low frequency energy, right? They're back vowels, right? And so I wonder if what we're getting here is an association with something that looks like if it bounced, it would go boom, 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 right? And the fact that the speech sounds are low pitch, right?
Yeah.
And so if that were the case, you would expect to be able to get these kinds of associations from non-speech analogs as well, right? So I don't know if that's for Ian or you, or if it's even really a question, but like, I think it is.
So I guess I will answer, and Ian should object, and people should let me know online if he's objecting. I think that's a really good question, and I think, there is whole frequency theory and all these other things. So there's a lot of, so I personally would think that would be very interesting to look into, and I don't think anything that we've shown so far in any way shows it has to be linguistic. So I think, and that would also, so I would be very intrigued in doing that. That's not really, that is a positive reaction to your suggestion.
Maybe as a follow-up, and just in case Ian is typing, this might account for why there's a round bias, right? Because humans have better resolution at low frequencies, and we're really attuned to those. We lose our higher frequencies as we get older, and not many speech sounds go above 5,000 hertz. So maybe low just pulls on you more is another thing I want to offer Ian.
Super interesting. Thank you. Yeah.
Hi, Tanya Ivanova-Sullivan, University of New Mexico. Thank you so much for this very interesting talk. And I do agree with you about categorization and binary oppositions, but I also think we're forcing people to choose one or the other. So obviously something is going on there. Have you tried, because you only do language processing in those experiments, have you tried asking people to produce, not to produce, but you give them a choice of several items, and then you ask them to choose an item to go with the picture, with the representation, the other way around, instead of you asking them which one they choose. You know what I'm saying?
Yes, so you mean giving them like a shapes and then giving them one sound and say which sound best matches,
Or
which
a
shape,
list of
which,
you know, words, not just the sounds. Or if you're going to go with sounds, you can do that as well. You know what I'm saying? You can do the sounds if you, right, if that's, or you can do, I don't know whether you were going to do Kiki and Booba as words in general to match with particular shapes.
well, so let me know if I misunderstood, but like, so at Anarphia, right, what she did is she gave people two shapes and then she gave them one
sounds.
auditory label. So
Okay.
is that what you were?
Something like that, but can you give them like a list of different things and then you ask them to match them, list of different auditory samples?
Oh, I see. Yeah, no, we haven't done that, but we definitely should. I feel like there's a lot of things that
I
we
was
should look
just-
into.
yes.
Absolutely. Yeah.
As a suggestion.
Yeah, thank you. And this was kind of a first step, kind of building a bit on some of the earlier work to see how could we shift like the pseudo impexment, but absolutely the different directions would be very much needed.
Hi, great talk. I'm Susan Tubner-Rhodes from Auburn University. I'm interested in the roundness, sharpness, asymmetry that you found. In the ambiguous condition, it looked like in the control group, they actually tended to categorize those as sharp, more so than round, that the error bars weren't hitting 50% there. And so I wonder if rather than a roundness bias is actually kind of a default sharpness bias that then the round label is pushing them away from.
You know, that is a great observation. And I know that actually Ian and I in the lab, we have talked about that, and I'm trying to reconstruct. That's something that we've pondered. Relatively speaking, we still find that the round labels and like the round labels differ from the controls, whereas the sharp labels don't. So that still holds. But you are right that like overall, it seems that people like to say things are sharp. So there could be this like baseline difference that could be due to our shapes having certain properties, despite that we normed them. But I think the fact that we still get the difference between the round versus sharp, I think that would still stand, but we should definitely think more about that. And maybe Amanda's point about the frequencies could be helpful there. And if you have any more ideas, I would actually love to hear them, as well. Thank you.
Okay, before you, Ian would like to contribute from afar. So
yeah, I just
I'll
wanted to
talk about
kind of
that.
jump in and add to that. Hi, can you hear me? Great.
Yeah.
I just wanted to add into that question and comment. Some of the participant feedback that we got about kind of the strategies that people use to kind of decide whether something was sharp or round, I think might contribute to why we're getting a little bit below baseline for some of the shapes. So some participants had very strict ideas about what something round was, that it needed to be very spherical, like very specifically like a ball-like shape, whereas something could be sharp if it just had any singular angle to it. So I think that like Elsi's point stands, we've kind of normed it and we're, should be able to trust, I think, how labels are interacting with it. But people, I think, have a much stricter definition for roundness than sharpness that might be playing into kind of the asymmetry we see there, at least in terms of the baselines.
Okay, thank you. Okay, so one final quick question.
Thank you. Chris Cummins, University of Edinburgh. Great talk, thank you. I had a related question to that, which was to do with the predictions about the speeding of responses. Presumably, if you're really on the cusp, I see why you're saying it's facilitatory. But if you're kind of lean round or lean sharp and the cue pushes you in the opposite direction, would you then predict a slowdown? Maybe is that why things could be equivocal?
That's a great point, and that's actually something that we were just talking about recently, Ian and I, because so far I just showed you the overall reaction times independent of people's response. So now I think the obvious next step is to look at it kind of in a response contingent way, and also just look more at the distribution overall of the reaction times to see, depending on what people said, what were their reaction times like, and what was the distribution of those reaction times? Yeah, because I actually, I agree with your thinking. So this is kind of so those RT data is the big next step we need to kind of poke at, if that makes sense. Thank you.
Thanks very much. So let's thank Elsi and Ian.